solving quadratic equations is that we have to remember how to simplify radicals. We have to understand how to simplify radicals. We do not have anything called decimals. We have what are called exact answers. And the exact answers are what we would leave them in called simplified radical form. Now, I'm going to show you a nice shortcut using your calculator if you forgot how to simplify radicals. It's great for like the square root of 24, square root of 90. It's not so great when you have the fractional amounts. Those we'll have to worry about working with what are called conjugates. So, remember, when you're dealing with simplifying radicals, what you're looking to do is break apart the square root to find the largest perfect square that goes into it. Now, in 24, you could probably figure that one out. What's the largest? No, wait, first of all, remember what are the perfect squares? 4, 9, 16, 25, and so on, okay? So what I'm doing here is I'm breaking this apart into the square root of 4 times the square root of 6. What's the square root of 4? 2. So my answer is 2 root 6. Okay? When I work with the square root of 90, I'm also looking for the largest perfect square. Once again, this one works out to be rather cleanly. It's 9. It's 9 and 10. Yes, sir?
Are we not allowed to bring in those calculators from like last year to carry on 2 calculators? Because then I could just solve them for us?
Yeah, I'm going to show you how to set some of these up a little bit easier. So this is root 9 and root 10, so you get 3 root 10. Now, with these types of values, what I want you to do is take your calculator out real quick. Go to your y equals, and I want you to type in, we'll look at 90. I want you to type 90 divided by x squared. Go to your table. Now, here's what you're looking for. As you go through your table, you're looking for the largest positive value in the y column that is still an integer. Whole number. Excuse me, the smallest one. Oop, I went too far. As I'm scrolling through with my positive values, 1 and 90, 3 root 10. That's how it'll do that for you. This will also work when we have to take care of cube roots. We have to simplify cube, which we'll do later. You would put it 90 divided by x cubed, and it does the same thing. So what I'm doing is I'm looking down my table. I'm looking for positive values of x. And when I have the largest value of y that's still an integer, that's what stays under the radical. That's what comes out. So it's 3 root 10. And the other example we had was 24. If I take 24 divided by x squared, go to your table again.
Oh my gosh.
Isn't that nice? I just learned that. It's pretty slick. All right. So it just takes a couple of keystrokes to go through that, and you can do that. Now, as far as the other style is concerned, when you have to worry about division, that means you have to take the square root of both the top, the numerator, and the denominator. And the one that says root 7 over 16, that one's easy. Because what's the square root of 16? 4. So what you wind up doing here is you're taking the square root of 7 over the square root of 16. So that's root 7 over 4. And you're done. What comes into play that's a little bit weird is when you have something in the denominator that you cannot simplify. For example, when you have root 7 halves, or 7 over 2. Here's what happens. When you have the square root of 7 divided by the square root of 2, you have to do something called rationalize the denominator. You do not like radicals in the denominator. All sorts of bad things. It's ugly, it's mean. It's just bad. So what you want to do is get rid of it. And you remember, how to get rid of it is that you're going to multiply it by a factor of 1. Because anytime I multiply by something by 1, am I really changing it? So a real easy thing, isn't root 2 divided by root 2 1? All right, what's the square root of 2 times the square root of 2? 2. Yeah?
Where are you getting the square root of 2?
I'm trying to get rid of this radical in the denominator. In order to get rid of it, I multiply it by itself.
I thought it was root 7.
No. I'm on the other problem. Because that one was root 7 over 16, so the square root of 16 is 4. You didn't have to do this. So here I get, what's 7 times 2? So I get the square root of 14 over 2. And I'm done. Because the square root of 14 can't be simplified. Okay? You did this last year when you guys worked with 30, 60, 90 triangles, all those root 3s. Same basic principle. It comes back every once in a while. Okay? This does come back every once in a while. But what this allows us to be able to do then, guys, is we're going to be able to set up and solve problems like this. Instead of factoring, we're going to solve using square roots. Okay? So think of these as, instead of 2-step equations, 3-step equations. Yay! Yay! So if I have 2x squared plus 1 equals 17, what's the first thing you're going to do? Subtract 1. So I have 2x squared equals 16. Now what do? No, I can't do that until I have x by itself. Divide by 2, I have x squared equals 8. Now, take the square root. Do you remember what the square root of 8 was? It's 2 root 2. Now, here's one thing I want you guys to remember. Anytime you take a square root over an equal sign, when you're solving a problem, if you're taking the square root of both sides, what do you have to put over on this side now? Yeah, very good. Plus or minus 2 root 2. When you're just simplifying square roots, you don't have to put the plus minus. You know, if I'm saying what's the square root of 90, that's just 9 root 10. But the minute that you're solving x squared equals 90, then you have to say plus minus 3 root 10. It's one of those rules that anytime you take a square root over an equal sign, you have to remember to put plus minus. Because remember, there's always 2 numbers that can give you that answer. Okay? I'm sure you probably have done something like this before. And you might not have been such a stickler as far as the plus minus, so I'm guessing. So let's look at another one. 1/3 times the quantity x plus 5 squared equals 7. What do you do first? Okay, multiply everything by what? 3. Yeah, multiply everything by 3. Get rid of the fraction. So now I have x plus 5 quantity squared equals 21. Now what do? What's that called? What's that called? Yes, you're right. No! Square root it. Oops. Do I have junk squared equals a number?
Yes.
Okay, what's the square root of junk squared? Junk. Hooray!
Your word for like eight.
I took the square root, I didn't square it. Alright? Because I undid squaring by taking the square root. Now, can I simplify the square root of 21? No?
No.
So my last step now to get x by itself is to do what? Subtract the 5. Now, one thing I would like you guys to get in the habit of doing is make sure when you move something over, you get -5 plus or minus the square root of 21. Make sure you put the integer in front of the plus minus sign. A lot of times students tend to forget that, and they put it behind it, and then they'll just write down plus or minus the square root of 16 and write 4, because they'll combine them by mistake. Okay? Put your integer in front of the plus minus symbol. It's more etiquette, if you want to call it. It's just a little bit cleaner to see. Remember, what we're doing here is we're solving equations to figure out a real simple way of setting these up. Now, this is another form of factoring. Okay? My zeros do lie at -5 plus or minus the square root of 21. You couldn't have factored that by unfoiling it, if you will. You wouldn't have been able to do that. But by doing it this way, you can get to those values. You can still find zeros. Okay. Now, the fun part comes into play when we mix it in with the negatives. Because the square root of negative 1 is
Jeez.
I. I love math.
Oh, no.
Because what happens now is that you have a complex number. Sometimes in these problems, you're going to wind up with doing all your algebra correctly, and you're going to wind up with the following. X squared equals negative 4. Okay?
What?
I get it.
What happens here is that I can't think of any number that's the same number that I can multiply together to get negative 4. But what I do have is a complex number. I have an imaginary number. I have a number that I can think about, but I just can't talk about. What happens is, thank you. What happens is, if you remember a while ago when we wrote out like the square root of 24 was the square root of 4 times the square root of 6, what I can do is I can break apart, when I take the square root here, I can break apart that 4 to look like, well, x will equal plus or minus the square root of 1 times the square root of 4. No, excuse me, negative 1. Because the square root of negative 1 is the imaginary. Yeah. It's I because it's imaginary, not because it ran out of letters and became slow. Okay. What's the square root of 4? And what's the square root of negative 1? I. So my answer here, when I say what is x squared is equal to negative 4, my answer is plus or minus 2i. What I'm doing here is anytime I have to take a negative square root, I basically bring out a negative 1. I simplify my radical like I would any other way. And I just got to remember to put the I in the answer. There will be other things that we'll have to do eventually with I as far as conjugates and things like that. But we'll worry about that tomorrow. Today I just want to set up and solve equations. The setting up and solving equations and the stuff that equals a positive value, you've done. This is just adding really one more step. Okay, this adds one more step. Let me show you another example. If I look at number 4 up here, it says x squared equals negative 9. X squared equals negative 9. So, I have nothing left to move around on the left-hand side there. I've got x squared. So I have to undo squaring. Once again, how do you undo squaring? Okay. So I took a square root over an equal sign. What do I have to write? Very good. So when I take the square root, I get x equals plus or minus, well, the square root of 9 is, well, the square root of negative 1 times the square root of 9. What's the square root of negative 1? And what's the square root of 9? So the square root of negative 9 is?
Plus or minus
3i. Okay? Remember, we're simplifying radicals just like we always have. The only thing is, if the radical is negative, you just bring out the you bring it out as an I. Okay. In 5, we have 2x squared plus 3 is negative 13. Subtract the 3, very good, so I get divide by 2, I get x squared is negative 8. And do you guys remember what the square root of 8 was? So what would be the square root of negative 8?
2 root 2i.
Put the I in front of the root. It's that etiquette thing again. Exactly. When you write this out, you're going to get plus, we all agree it's plus minus, right?
Yeah.
And we all agree the square root of 8 is 2 root 2.
Yes.
When you have to throw an I value in there that you were able to factor something out of your perfect square, you put it after the integer before the root. 2i root 2. It's just the proper way of writing it. Square root of 8 is 2 root 2. Square root of negative 8 is 2i root 2. Square root of negative 12 would be 2I root 3. The square root of negative 18 would be 3I root 2, and so on and so forth. All you have to do when you're simplifying radicals, if a value was able to come out of as a perfect square and it's negative, just put the I value between the integer and the radical. That's the only rule they have with these. Okay? Don't forget plus minuses. On number 6, I have junk squared equals negative 7. Take the square root of both sides. So what's the square root of junk squared? Junk.
I mean,
So I have x minus 1 is plus or minus square root of negative 7. What's the square root of negative 7? I root 7. Very good. Now, do we also agree that I have to move that 1 over? Do I put the 1 in front of all of it or after all of it? In front of it. So I get x equals 1 plus or minus I root 7.
so basically, I was just saying,
I'm sorry, what was that? No, because once I take the root, once I take the square root of the negative, I comes out, it's just I root 7. Because if it was I root negative 7, then it's really weird stuff then. There is, but it doesn't simplify it. They use the imaginary, what you can do with imaginary numbers is you can do some of these weird Mendelian plot thingies, and I don't even know if you want to bother programming that. Okay. You have to do some programming. All right, try this one. Try that one. Same basic principle, same basic idea. No.
what does it mean? I tried to here, and it was, it's non-responsive. So you're.
So far, so good? Okay. Is it negative 49?
Yeah.
What's the square root of negative 49? 7i. So now when I take the square root of both sides, I get x plus 5 is plus or minus 7i.
Negative.
And I put the negative 5 in front of it. Exactly. So then I get x equals negative 5 plus or minus 7i. And that's just the proper way of writing that out. You just put the integer in front of the imaginary. That's all. Remember, you're setting up and solving these equations just like you guys have in the past. The only twist to it is that if there's a negative value, you have to remember about I. Okay? So I think about another one here. I think that's enough for now. You know what? That will be, because that's perfect, because that gives us plenty of time to do some work in here. And then tomorrow we'll talk about how you add imaginary numbers together, multiply imaginary numbers together, and divide them. There's a couple of rules with that. It's not that bad.
So we're doing both.
Yeah, these are two different sections. This was the stuff without imaginary. This is with imaginary. The setups that I'm giving you guys, the first handful of them are just simplifying of radicals. And then I gave you, what, 10 total of solving equations. So it's not so bad. Okay. And I gave you all the solving equation ones are odds, so you can check your answers. I will tell you one thing, the back of the book tends to write their answers weird. So if your answer doesn't look exactly like the back of the book, but yet you think you got it right, you're probably fine, and I'll explain to you what they're doing tomorrow. Okay? I'm not going to really worry about going so far as fine. Okay? You guys got some time? I'll put the problems up on the board so you can start taking a look at them. Wait. I just wanted to, well, I'll wait a second. I didn't know where to pause, I guess.
Wait, for 51 through 67, do you do all of them?
Odds. They're odds. Yeah, these are odds also. This is all odds here as well. Okay. Let me pause.